Very good morning. Welcome to the week 8 lectures of applied multivariate statistical modeling. In this week we will see multiple linear regression. Today I introduce the topic. You will know dependent variables, independent variables, multiple linear regression equation and multiple linear regression equation in matrix form. Let us see the next.
Today we will discuss multiple regression. The contents of multiple regression are: first we will start with a conceptual model. Then we will describe the estimation of parameters. Then we will go for sampling estimation of parameters in terms of beta vector. Then sampling distribution of beta estimated. Then we will go for sampling distribution of error. Estimated. Then we will go for that model fitting issue, that is adequacy of a regression model. Then we go for test of individual regression parameters, that is all betas. After that we will test the assumptions related to regression. Then there are certain diagnostic issues. Then prediction using multiple linear regression. Finally, a case study will be shown. So this is in totality will be covered under multiple regression. So we will go by the first the model, then estimation of parameters, sampling distribution. I think today we will be able to cover this one, conceptual model and estimation of parameters. I think this is for 1 hour. Then sampling distribution of that beta estimates and sampling distribution of error estimate. I think 1 more hour is required there. Adequacy of regression and this test of individual parameter may be 1 more hour. Test of assumption 1 hour. Then diagnostic issues 1 hour and prediction 1 hour and case study 1 hour. So 1, 2, 3, 4, 5, 6, almost 6 hours we will be discussing on multiple regression. Now let us start with an example. I think in first class and also in subsequent lectures I have given one example for the CTCAN data. CTCAN is a small company working in the local market, and we have seen that the data structure was like this. Other way we can start with the variables. The important variables for this particular company are profit, then sales volume, then they have found out the percentage absenteeism of workers or employees. Then related to machine, that machine breakdown hours monthly. Then they also have a marketing department whose performance is measured through M ratio. The company's primary interest is how to improve the profit, that definitely through maximizing the sales. And apart from many other things, the company is interested to know how these three variables, the absenteeism, breakdown hours and M ratio, is affecting sales volume as well as affecting profit. If this is the case, then under this situation there are two types of variables. One called dependent variables or dependent variable DV, another set is known as independent variable, which is IB, independent variables IVs. So, in this case profit is one dependent variable, sales volume is another dependent variable, and there are three independent variables like absenteeism, breakdown hours and M ratio. Now, what is of interest in this particular case? Here we want to test that whether the independent variables are contributing in explaining the dependent variable one at a time, it is happening or not. If we can find out that yes, there is influence of the independent variables on the dependent variable, then depending on the influence measure, some actions can be taken to control the dependent variable with the help of controlling the independent variables. So, pictorially, if we now consider that one dependent variable, let it is sales volume, which is y, we are denoting like this, and other variables we are denoting like this, x1 equal to percentage absenteeism, x2 equal to breakdown hours, and x3 is M ratio. So, we are not considering profit at present, later on we will see that how profit also can be included. So, under this situation, if I define like this, that y within a circle or ellipse and x1 within a rectangle, x2 with another rectangle, x3 with another rectangle, and I can create some straight line with curved with the arrowhead to y, then this will determine that the respected IVs are influencing the dependent variable y, that is the measure. So, that means x1 influences y, that is why the arrowhead emanates from x1 and terminates at y, that is the case. Okay. So, we can say that if x1 has influence of beta 1, x2 has influence of beta 2 and x3 has influence of beta 3. What does it mean? It means that if I change 1 unit of x1, there will be beta 1 unit of change in x2. If you change 1 unit of x2, there will be beta 2 unit change in y, and if you change 1 unit of x3, there will be beta 3 change in y. Repeating, if you change 1 unit of x1, there will be beta 1 unit change in y. Similarly, if you change 1 unit in x2, there will be beta 2 units change in y. 1 unit change in x3 causes beta 3 units changes in y. Okay, this is the meaning of these influencing parameters. Now, what will happen, suppose none of them for example, absenteeism, breakdown and M ratio, none of them contributes to Y. Will there not be your cells? Is it, there will be cells also. It is not necessarily that they have to contribute always. So, in that case we require some other parameter which is known as beta 0, that is coming through x 0, where x 0 takes value of 1, that is always, okay, x 0 equal to 1 always. By saying this, what we are trying to say, that even if there is no influence of x 1, x 2, x 3, still there will be some amount of y values. This is the constant term beta 0 is added there. Now, if you take one observation of y followed by second, third like this, what will happen? You will find out that you are not able to explain using beta 1, beta 2, beta 3 and beta 0 and all these values, not able to explain the total variability in y. That means there are some other variables or some other, either they are controllable or uncontrollable variables are there, which are also contributing towards the variability of y. So, as a result, what we require? We require another measure which is known as error. That means in multiple regression case, you will get three types of, I can say, parameters. One is beta 0 constant parameters, which is known as intercept. Then the influence of the independent variables, these are known as that influencing parameters or regression coefficients. Also beta 0 is also regression coefficient, intercept coefficient. Then another one is a random one, which is error, which also contributes. So, essentially then what will happen, if I want to put the entirety in terms of an equation, I can write like this: y equal to beta 0 x 0 plus beta 1 x 1 plus beta 2 x 2 plus beta 3 x 3 plus epsilon. You can very well write this one. So, that means this figure is the pictorial representation of multiple regression model, which in mathematical term you can write using an equation. Okay. Now, as we have said that x 0 will take value of 1 always. So, this can be written like this: beta 0, beta 1 x 1, beta 2 x 2, beta 3 x 3 plus epsilon. Okay. Now, if we generalize this one, that we are not interested only in 3 variables, we will go for a variable vector which is having what I can say p variables, let it be. So, I am writing like this: x 1, x 2 dot 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 x p. So, there are p variables which are contributing towards y. Okay. And as we have already seen, there is one intercept parameter, and with related to one constant x 0, that one we are making it 1. So, we can write, if we want to create this x in terms of, also we want to add x bar x 0, then you can write this one p plus 1 into 1. See, this x 0 is it is not required to be written here, later on it will be taken care of. Essentially, this x 1 to x p is the variables IVs, x 0 is a constant, that intercept term will come for that. Okay. So, okay, then if we go by x 1 to x p, this is p cross 1 variable vector. Under this situation, what will be the beta because there will be influence for each of the variables. So, I can write beta 1, beta 2 dot 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 beta p, which is p cross 1, but see there is one intercept parameter related to x 0. So, that is beta 0. So, you require to estimate p plus 1 parameters, regression coefficients here. Okay. Now, I can write now like this: y equal to beta 0, beta 1 x 1, beta 2 x 2 dot 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 beta p x p plus epsilon. So, this is in general the general regression equation. Okay. This is the general regression equation. You can write later on we will write it in terms of matrix equation. Okay. Now, let us assume that you are collecting data. So, let n data points are collected. Or you can are collected or to be collected. If you say to be collected, this will be all observations will be random. So, in this case, so our data matrix will be, first one is the dependent case. So, y it will be y1, y2, y3 like your yn, n data points. Then you are collecting x, that will be n cross p. N is the number of observation, p is the number of variables. So, we will use here x11, x12, x1p, x21, x22, x2p. So, like this xn1, xn2 dot 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 xnp. Correct. So, this is related to IVs, these two sets of data you will correct. Now, if you use this data set into the equation given here, so for every data set or every data points, this equation will become true. So, in order to incorporate that every data points into consideration, if I write one yi here and then here it will be xi1, xi2 like xip. This is what we are saying the general observation related to this. Now, if we want to write the equation here, then what we will write? We will write yi equal to beta 0, beta 1 x i1 plus beta 2 x i2 plus beta p x ip plus epsilon I. Getting me? Then what is this quantity? This quantity you see, it is a weighted linear combination of several variables. Here basically multiple random observations. So, can we not write down this is variate? This is linear combination, weighted linear combination, this is variate. Then what does this variate represent? In this case, this one represent the expected value of yi given xi. What is this? Xi equal to basically xi1, xi2 like this xip. Getting me? Without error term, this one is the expected value of yi if I know the ith observation for the individual variable IVs, then what will be the expected value, what will be the value of yi, that is the predicted value. As we do not know that what are these IVs for the ith observations, so accordingly we also do not know what will be the yi value, but by this variate we are basically saying that what will be the expected value of yi if you collect ith observation xi1 to xip. Okay. And then that means what is happening, then yi equal to this plus epsilon I. So, this expected value is nothing but the predicted value. Okay, suppose you want to use this later on, this will be the predicted value. So, I can write from here that epsilon I equal to yi minus yi cap. So, essentially what are the things we have found out here? We have found out all the coefficients, regression coefficients, also the error term. Also that, and we also describe that that this linear combination of this is the variate, and this variate will basically talks about what will be the value of expected value of y given this condition. So, it is a conditional y. We also write this one that mu of y given x in general term, we will write mu of y given x. If I say yi, then given xi, where xi is, this is the xi observation. Okay. Why so? If we further assume little bit, this is because you just assume that there is one x and one y, and you are fitting a linear line. Suppose this is your xi, and so what will be if this is the regression line, the linear line, then you go like this, you will be meeting, you are getting this point here. What is this value? This value here, this is nothing but this value mu, mean value of y for the ith observation, given ith observation. Now, why we are talking about mean value? The reason is, suppose you collect for the ith observation, if you collect one now, you will get some value here. If you collect tomorrow, the value may change. So, ultimately there will be one error part. So, this one is taken care of by the concept error. So, any point on this regression line which you will be fitting later on, these points are the mean value of y given x. Okay. So, we will see later on when we will fit all those things. I will tell you that how to make all those things. Okay. Now, we have collected see n data points, and we have also our regression equation that yi equal to beta 0 plus beta 1 x I1, beta 2 x I2, like this beta p x ip plus epsilon I. If I write it for all the observation, then y1 will be beta 0 plus beta 1 x 11, beta 2 x 12, like this beta p x 1p plus epsilon 1. For y2 you will be writing like this beta 0 plus beta 1 x 21, beta 2 x 22 plus beta p x 2p plus epsilon 2. If you go on writing, ultimately up to the nth term, you will be writing like this beta 0, beta 1 x n1, beta 2 x n2, beta p x np plus epsilon n. So, if I write in matrix form now, can I not write y1, y2 like yi, then yn for the left hand side? You can write this. So, this is n cross 1 vector. I can write this equal to, if here for beta 0 there is only 1, that x 0. So, 1, 1, 1. For beta 1 x, what is this? 1 1, x 2 1, x I 1, x n 1. For beta 2 x 1 2, x 2 2, x I 2, x n 2. Similarly, for beta p x 1 p, x 2 p, then x I p, then x n p. Fine. So, this one is now what will happen here? There are n into p plus 1, p variables, 1 for the intercept. So, if I multiply it by beta 0, beta 1 to beta p, this will be p plus 1 into 1. Then the multiplication of this will give you n cross 1. It is giving you n cross 1. So, n cross 1 equal to n cross 1, which is basically this portion is taken care of by this, plus there is error terms epsilon 1, epsilon 2, epsilon I, epsilon n. This is n cross 1. Okay. So, the resultant can be written like this: y equal to x beta plus epsilon. Okay. So, where y is n cross 1 vector of observations of the dependent variables, x, this is n into p plus 1, the data matrix of IVs including intercepts. This is also known as data matrix. Actually, x is this one including intercept. So, we say this one is design matrix. Correct. Beta is the p plus 1 cross 1 regression coefficients, and epsilon, this is n cross 1 error terms. N cross 1 error terms. Fine. So, this is in nutshell equation for multiple linear regression in matrix form.